Hi students, very good morning to all. Today we are discussing the one of the important topic of ultraviolet spectroscopy, and the name of the topic is the calculation of wavelength by using Woodward and Fisher rule. Basically, Woodward and Fisher are the two scientists who give the rule to calculate the maximum wavelength for the two components, basically dienes and dienophiles. Okay. So today we are going to discuss Woodward-Fisher rule to calculate wavelength for Diene system. Okay. So before we start discussion how to calculate the wavelength for Diene system, let me first explain what are the dienes. Okay. So Diene, the name itself indicates that di stands for two and ENE stands for double bonds. Okay. So when two double bonds are in conjugation, that system is called as Diene system. Okay. Now let us see example. This is one double bond, and this is in conjugation with another double bond. This system is called as Diene system. Now I will write one more structure. This is one double bond, and this is in combination with another double bond. It is also a Diene system. But the difference is that one is cis diene and another one is trans diene. Okay. So please note this important concept. What is cis diene and what is trans diene? Cis diene is also called as cisoid, and trans diene is also called as transoid. Okay. Now the two scientists, one is Woodward and second one is Fisher, gives a theoretical rules to calculate the maximum wavelength for Diene system as well as for dienophile system. Okay. Now in today's lecture we are going to discuss how to calculate wavelength of Diene system. Okay. Once again I repeat, dienes are of two types. One is cis and another one is trans. Okay. Now next, as I said earlier, dienes are of two types. One is cis conformation. One is cis. So this is the cis diene, and another one is the trans conformation. Okay. Now this is the homoannular diene. Sorry, it is heteroannular diene. Heteroannular means what? Look at here. This is one 6-membered ring. This is another 6-membered ring. One double bond is present in one heterocyclic ring and another double bond is present in another heterocyclic ring. Okay. So such system, when two double bonds are present in two different rings, that system is called as heteroannular diene. Okay. That is also called as transoid diene. And when two double bonds are present in the same ring, this is called as homoannular diene. Are you getting? So in this slide, there are four types of diene. One is cis, another one is trans, one is homoannular, and another one is heteroannular. Okay. When two double bonds are present in different rings, it is called as heteroannular, and when two double bonds are present in the same ring, it is called as homoannular. Is that clear? Okay. Next. Now, this is the empirical rule for the Diene system, which was proposed by Woodward and Fisher. Okay. Now, this is for homoannular diene and this is for heteroannular diene. Okay. So the formula for the calculation of theoretical wavelength, maximum wavelength for Diene system, Woodward has given an empirical rule, and the rules are in front of you. First, the empirical rules for Diene system. First, for the parent, the basic lambda max value for the homoannular diene is 253, and for heteroannular diene it is 240. Okay. So when our Diene system is homoannular diene, its parent value is 253 nanometer, and when our Diene system is heteroannular diene, its base value is, parent value is 240 nanometer. Okay. Now Now there is increment for, means in addition to the base value, if there are another component in the structure, we have to add some nanometers. Okay. So first point is double bond in conjugation. Okay. Let us see, this is example. Suppose this is one diene which is transferred, and if there is another double bond which is in conjugation. Okay. If such case is there, now for this double bond, extra double bond which is in conjugation, we have to add 30 nanometer in both cases. Okay, we have to add 30 nanometer in homoannular diene, and we have to add 30 nanometer in heteroannular diene. Okay. Now, if there is alkyl substituents or ring residue, for that there is increment of 5 nanometer. Okay. For that there is increment of 5 nanometer. Look at here, 5 nanometer. There is increment of 5 nanometer. Are you getting? This is for alkyl group or ring residue. Now the third is, if there is exocyclic double bond. In my next lecture I told you what is exocyclic double bond. You simply remember the figure. For exocyclic double bond there is addition of 5 nanometer. If there is acetate group, there is no increment, 0, 0. For the alkoxy group, there is increment of 6 nanometer in both the cases. For chlorine and bromine, we know that chlorine and bromine are the halogen. For that, there is increment of 5 nanometer. And if there is a tertiary amine, if present in the given structure, there is increment of 60 nanometer. Okay. So this table, once again I repeat, this table indicate what are the values of base values, what are the parent values, increments for double bond in conjugation, exocyclic double bond, alkyl substituents, etc. Okay. Now next. Now by applying this rule for the examples, we will get the clarification of the Woodward-Fisher rule. Look at here, this is the transferred. First example is the transferred compound in front of you. And we know that for the transferred, base value is 214. So 214 is the calculated value, and look at here, the observed value is 217, which is very close to the calculated value. So this is the benefit of Woodward-Fisher rule. Now second component, it is a transferred, therefore the parent value is 214. Beside this, it has 3 alkyl substituents. This is one, this is second, and this is third. And we know that for one alkyl substituent is the increment of 5 nanometer. So 5 multiplied by 3 is 15. So sum is 214 plus 15. The calculated value is 229 and the observed value is 228. Similarly, another 2 examples are there. This is an example of heteroannular diene, and this is also example of heteroannular diene. Now, in first case, this is heteroannular diene. There is the base value is 214. Okay, 1 minute. Now, ring residue, there are 3 ring residue. Therefore, for that 15 nanometer, we have to add 15 nanometer. Exocyclic double bond is present. This is exocyclic double bond. This is exocyclic double bond. Look at here. And for that, there is addition of 5 nanometer. So the calculation is 214 and the observed value is 241. So by using Woodward-Fisher rule, we theoretically able to calculate the maximum wavelength of compound in ultraviolet spectroscopy. Okay, these are the 2 examples. Okay. Now, exocyclic double bond. What is exocyclic double bond? The double bond which is outside the ring. Okay. So this double bond is outside the ring. This is another 3rd example. And 3 multiplied by 5, therefore 15 nanometer. Okay. As I told you, the exocyclic double bond is a double bond that lies outside the given ring. Means the double bond which is outside the given ring, that is called as exocyclic double bond. Okay. Now these are the 2 last examples which I explained on the Woodward-Fisher rule. The first one is, look at this structure. By observing that structure carefully, we come to know that this is the heteroannular diene, because these two double bond, this one double bond and this another double bond, they are in conjugation and which are present in the two different rings. Therefore, it is heteroannular diene, and the parent value for the heteroannular diene is 253. There is one double bond extending conjugation. This is another double bond extending conjugation. So 2 multiplied by 30, 16. There are 5 ring residue. So 5 multiplied by 5, 25. 2 exocyclic double bond, 15. And the addition is 353, which is the calculated value, and the observed value is 355. Okay. Similarly, this is another example which also illustrates the Woodward-Fisher rule. This is the homoannular diene. The parent value is, it is cissoid. The parent value is 253. One alkyl substituent, 3 exocyclic double bond, 3 ring residue, 1 exocyclic double bond, and the total value is 273, which is close to the observed value. So, dear students, in today's my lecture, we had discussion on how to calculate Woodward maximum wavelength by using Woodward-Fisher rule. Thank you very much.